All right, welcome back. Today we're going to do section 6.1, which is roots and radical expressions. So today will be a little bit heavier on the vocab. Our EQ is how do I simplify radical expressions? We first have to define what that means. But as a quick warm-up, if you don't know how to do this on the calculator, I'm going to show you very quickly. But it is how to evaluate something like the square root of 25. Now, most of us know that the square root of 25 is 5, because the square root means what number times itself will give you the given value. In the TI calculators, the square root button is right over here above the squared. So if you hit second, and then the X squared button, it pops up with the square root. You can type 25, hit enter, and we get 5 as a result. Now, on something like the third root of negative 27, this is now saying what number to the third power gives a result of negative 27. And you may be able to do that in your head, but again, I'm not going to, if there's a way to do it easier on the calculator, I'm going to show you how to do that. And so there's no button for the third root. If you hit the math button, you'll see the third root is this fourth option down here. So if you hit math 4, then that's asking you for the third root. I would type in negative 27 and get negative 3. So if we come back here, this cube root of negative 27 is negative 3. And then finally, the fifth root of 32 means what number to the fifth power equals 32. Again, it's not just 32 divided by 5. And to type anything, so if you look in the math, again, in this math, hit the math button, look in the math folder of the calculator. There's a third root option, and then there's this X root option. So if I hit the button 5, now what's tough is to show that I want the fifth power, I need to have first hit the number 5 on the calculator. So I'm going to go ahead and clear this out. And to type in the fifth root of 32, I'm going to hit my 5 for the fifth root, and then I'm going to do math 5. And you'll see that on my calculator, it puts the 5 up in the square root symbol. And then we type 32, and we get an answer of 2. So the fifth root of 32 is equal to 2. Again, you may have been able to do that in your head, but I do want to talk a little bit about the vocab for those things. Really, these words on the right side are the big ones that I need you to know. That little number, in this case the number 5, meaning the fifth root, is what we call the index of the radical. So the small number is the index. The radical sign itself is what you think of as the square root symbol. We call that the radical sign just because it's not always square root. We saw you can have third root, fourth root, and so on. And then the final new word of the day, and this is one that I'm going to try and stick with as much as possible, is what's called the radicand. And that is, the radicand is whatever number or variable or expression is underneath the radical sign. So whether it's the fifth root or the square root, whatever, the radicand is what comes underneath it. On the left here is some other lingo that's not as important. If you type in the square root of 4 in a calculator, you're going to get 2 as the answer. And we call 2 the principal square root. Principal square root meaning the main square root. But we do also need to understand that negative 2 raised to the second power also gives me 4. So there's 2 different square roots of 4. There's positive 2 and negative 2. But we'll talk about this a little bit more. If you just see this on the paper or on a test and it asks you to simplify that, you are only going to simplify that to positive 2 or the principal square root. So because 2 to the third power is equal to 8, we say 2 is a cube root of 8. And the nice thing about cube roots is there is only one, and we'll see how that works shortly. And then finally, when we could keep going with this, 2 to the 4th is 16. So 2 is one of the 4th roots of 16, -2 being the other possible 4th root. So again, not so much on the left side that's important, but these 3 are the big ones. The index, the radical symbol, and then the radicand are all ones that we need to be able to have in our vocabulary so we can talk about what we're looking at. So go ahead real quick and type these either in your calculator, or if you know it in your head, you can go ahead and just jot it down. What are the real cube roots of those numbers? So go ahead and pause if you want, type it in, and then we'll come back. All right. So if I wanted the cube root of -343, again, cube root is accessible on your calculator. You can do math 4. I just like, if I'm not doing square root, I'll always just, to do the 3rd root, I'll do 3 and then math 5 to get the cube root of -343, and that is -7. And then if I keep going with this, the cube root of 125 is +5, not -5. Understand that -5 is a cube root. If I was asking you to do the cube root of -125, that would then give me -5 as a cube root. But with 3rd roots, there is only one number for each one of these. If I keep going, the cube root of 216 should be 6. Cube root of -1000 should be -10. And the cube root of 1 should just be 1. And then at the bottom here, every real number has how many real cube roots. And that answer is simply 1. Every single number, both positive and negative, has 1 real cube root. All numbers. Okay. That does not hold true when we talk about 3rd roots or 4th roots. So if you type in the 4th root of 625 in the calculator, again, just to show, I like to do my index and then just hit math 5. So the 4th root of 625 is +5. But we also know that if I take the negative version of that same number and raise it to the 4th power, I'll also get 625. So there's actually, there's actually 2 answers to this. There is +5, which is the principal 4th root, but also -5 works as well. So there are 2 real 4th roots for that. The 4th root of -1296. So here's what some students will do. If they see the 4th root of -1296, forgot the negative sign. So it says non-real answer. And students tend to not like that. So they'll go back, they'll delete the negative sign. They'll say, oh, the 4th root of 1296 is +6. So then the answer for what I'm looking for must be -6. And that is not true. When you are 4th rooting, just like if you're square rooting, you cannot square root or 4th root a negative number. At least you can't do that and get a real number back. So when we're talking about find the real 4th roots, find the real 4th roots of the number, there are none for -1296. For -16, there are also none just because it is a negative value. And then for 14,641, we can go here for math 5, 1, 4, 6, 4, 1, and we get 11. So on here, what are my real 4th roots? 11, but we also have to understand that -11 works, is one of the 4th roots as well, because either one of those numbers raised to the 4th power will give me 14641. So every real number has how many 4th roots? if the number is positive, if it's greater than 0, then there are 2 fourth roots. If the number is less than 0, or if it's negative, there are none. And that's something that you're probably quite familiar with square roots, but we don't do with fourth roots all that often. So third roots have, every number has 1 third root, and then positive numbers have 2 fourth roots. The same is true for sixth roots and so on. So a little graphic organizer here real quick. If my index is even, so again, index being the number right here. So for instance, the fourth root, and my radicand is positive. So the fourth root of a positive number, how many real roots will this have? Well, we just saw this has 2 real roots. What happens if I take the, let's use a different index. What happens if I take the sixth root of a negative number that has none? If I take the third root of a positive that has 1 third root, and also same thing goes for negative numbers. There is 1 third root for each of those. And I could change this. The same holds true if this were a fifth root or a seventh root or whatever. So if your index is even, then it depends on the situation. If the index is odd, it's always 1 real root. So this is an important distinction in math. If I ask you to simplify something, so just take this and make it simpler, and you see something like the square root of 49, that is only looking for the principal square root or the positive version of it. So if you see square root of 49, you're just going to take what the calculator tells you, and this is just simplified into 7. Okay, you don't have to worry about listing positive 7 and negative 7. If you see square root of 49, just replace it with the number 7, and you're good. Where this is different is if it's an equation. So if it says what number to the second power equals 49, there are 2 solutions for that. We know there are 2 numbers that make that true. This is both positive 7 and negative 7 are both solutions. So what can happen here is students can think, oh, in order to get rid of a squared, I know, and we learned last try, that I can square root both sides, so I get x equals 7. And then you leave it at that and you just circle it and call it good. This is where if you square root both sides of an equation, and we'll hammer this throughout the try, if you square root both sides of an equation, you have to put that plus or minus, which then represents x is positive 7 or negative 7. So however you want to write that, but just understanding the difference between, if you see square root 49, that is just simplified to 7. If you see the square root, or if you see an equation that has a squared in it and you find yourself square rooting, then you need to introduce that plus and minus. Okay, now this is really, like, up till now, it's stuff that you've seen before. This is where we're going to get a little bit, this is going to seem silly and simplistic, but there's a reason why we're talking about this. So if you're asked to square root the quantity -5 squared, we know that if I take -5 and raise it to the second power, I'll get positive 25, because -5 times itself. And then, as we just mentioned, the square root of 25 is asking for the principal square root or the positive version. So my result there is 5. If I do the same thing for this, I don't know what 6 to the 4th power is. So we type this in to the calculator. 6 to the 4th, I believe, is 1296. Okay. Whoops. So here we have, this now becomes the 4th root of 1296, which, if I go back and type that into the calculator, the 4th root for math 5 of 1296 returns me to just the number 6. So as you can see in this case, it basically, the power and the index or the radical essentially cancel each other out and gave me just the number 6 back. We'll see that sometimes that happens and sometimes it doesn't. So for this, if I wanted to take the third root of -4 to the third power, -4 to the third power is -64. Again, because I'm taking a negative number and multiplying it 3 times, I end up with a -64. So if I come back here, the third root of -64 plugged in the calculator is -4. So then if we fly through these last 3 real quick, this is the fifth root of I don't know what. It doesn't really matter because the fifth root and the fifth power are going to cancel each other out. 59049. 59049. But when I take the fifth root of a positive number, I get a positive number back. Same thing here. If I take -3 to the fourth power, that gives me positive 81. But then if I type the fourth root of 81 into the calculator, it's only going to give me the positive, and that's what we're looking for, is just the principal square root. And then finally here, if I do the same thing with 11 to the third power, that's 1331. If I then cube root that, I get 11. Might seem kind of silly, and we know that a square root and a squared undo each other. But what we didn't really talk about last try is that there were 2 situations here where the radicand, the number underneath the square root, was different from the final answer. Here we had a -3 underneath the radical sign, underneath the fourth root, and it came out to be +3. And if you look in, the weird thing is, you might say, okay, well, yeah, that obviously happens with negative numbers, because there's a -5 turned to +5, and -3 turned to -5 turned to +5, and -3 turned to +3. But here we see that -4 remained the same with and stayed -4, and what separates that we can see is that the 2 in pink were the square root and the fourth root, so the index was even. And then for this last example, this -4 to the third power, that was an index that was odd. And so that returned us back the exact same value that we started with. Again, seemingly inconsequential right now, but once we get into simplifying radical expressions that contain variables, so x, y, z, this is going to be an important fact. So we're just going to write this out. I'm going to tell you how this goes, and then we'll see how it works. If the index is even, meaning you have the third root, or sorry, the square root, the fourth root, the sixth root, whatever. And when you simplify your answer, so if you have an even index, and when you simplify your answer, your variable has a odd power, okay, an odd power, you need to use the absolute value bars. And just a reminder, absolute value are these tall vertical bars. So what the absolute value does to a negative number is it turns it positive. That's kind of the big thing for this lesson, and it's kind of a weird concept as to why we do that. I'm going to try and explain it, and if this is something we have to talk about tomorrow, then that's fine. Okay, so if I want to simplify an expression that contains variables, this square root symbol we can see is applying to 3 different variables. I have the square root of x to the 6th power, I have the square root of y to the 8th, and I have the square root of z to the 10th. I'm just going to take each of those square roots individually, and then we'll kind of put it all together at the end there. So to square root x to the 6th power, you might already know how this simplifies, but if not, you can see that I can write this as x to the 3rd to the 2nd power, right? Because yesterday we saw if you have exponent raised to another exponent, you can just multiply them together. And since this is a square root, essentially what happens is the square root and the squared undo each other, and I'd be left with x to the third power. If I write out this, if I write out this next one the exact same way, I've got the square root of y to the fourth, which would then raise to the second. I can then cancel out the 2's, and I get just y to the fourth. And then finally here, the square root of z to the 10th can be written as square root of z to the 5th. Then that's raised to the second power. This then gives me just z to the 5th. But this is where we have to take into consideration. We know that when you square root a value, when you square root a number in the calculator, we are looking for the positive number and only the positive number. The problem with this answer right now is that I don't know for sure that this is going to be a positive value. Because it's to the third power, if I had a negative number raised to the third power, I would have a negative as a result. And so what I need to do is I need to put this x to the third in absolute value bars. Okay. For the y, again, I'm square rooting, so I want a positive value out. Since I'm raising this to the fourth power, I don't need absolute value bars because any number that you raise to the fourth power will be positive, so I don't need to put that in inside an absolute value. By that same argument, z to the 5th could be positive or negative, so I do need to apply these absolute value bars around this problem. How you write your final answer is up to you. You could write it just like this as it looks. Some people will put the absolute value after, so they'll put x to the third and then z to the 5th. How you write that doesn't really matter to me. If you want to keep it all separate like this or like that, that's perfectly fine. What I'm more concerned with is that we put the absolute value on the variables when we need to. So that's kind of a confusing one, and I understand it is, and it's okay to be not super clear right away. What we'll see is that since I'm third rooting, right, my index here is a 3, so I don't care if my answer is a positive or a negative, because when I'm third rooting, I can get either a positive or a negative answer back. And what that allows me to do is when I split this up into a to the 12th and the third root of b to the 21st, I don't need to worry about absolute value in this problem at all because my index was odd. And if you go back to the last slide, we said the index has to be even and your final answer has to be an odd power. Okay, so here I can rewrite this, and if you know the shortcut, you're saying to yourself, you don't have to do this, just do the shortcut, and I'll tell you the shortcut in just a second. Again, I can rewrite a to the 12th as a to the 4th raised to the 3rd. These 3's then cancel, and I'd be left with a to the 4th power. If I do the same thing with b to the 21st, that's b to the 7 to the 3. Again, the 3's cancel, and I get b to the 7th power. And I don't need to worry about, again, don't need to worry about absolute value because this was an odd index. It was the third root, so I don't have to worry about it. So that's where it gets a little dicey. We're going to look at a couple more examples of this quick, and then the end of 6-1. So what happens if you throw a number in there? So what happens if I take the square root of 64, x to the 10th, y to the 16th? I'm going to break this up into 3 separate square roots. So I got the square root of 64, square root of x to the 10th, and the square root of y to the 16th. Now the square root of 64 is something that I can type in the calculator, or you could, if you know the square root of 64 is 8, that's awesome. But if you have to type it in, don't feel bad about typing in something like that into the calculator. So that's going to be 8. Some of you may already know the shortcut. In order to simplify the square root of x to the 10th, all I'm going to do is take the exponent and divide by the index. So I'm just going to do 10 divided by 2, and that's going to give me x to the 5th. And if I do the same thing here, 16 divided by 2 is 8. It's important to know that I only divided because it was an exponent. What I don't want you to do is to say, oh, the square root of 64 then must be 32 because 64 divided by 2. That trick or that rule only works if there's a radical and then a power underneath. If we apply our rule from a couple slides back, we are square rooting. So I need to know that my answer is a positive. And the only part of this, of these 3 pieces, the only part of this that I don't know for sure is going to be positive is x to the 5th. I know y to the 8th is going to be positive because it's an even power. And I know the number 8 is already a positive value. So I need to put absolute value signs around this. Again, if you want to group together the stuff that's not in the absolute value and then put the absolute value at the end, that's fine. And this is how I'm normally going to write it. But just kind of a heads up that way. That is how you would write your final answer, your final simplification for that. Okay, so for the second one, if I'm going to third root negative 343 and third root x to the 3rd and third root y to the 15th, the third root of negative 343 you could type in the calculator. I actually just did that and I got -7 as a value. So this is -7. The third root of x to the 3rd, if I take power and divide by index, I get x to the 1st. But because the index was odd, I don't have to worry about absolute value at all for this problem. And then here, 15 divided by 3 is 5. So that is x to the 1st and y to the 5th. Okay, so for that, I know that I'm going to be absolute value is just something that doesn't have to come into play. All right, for these last 2 problems, go ahead and pause the video, give it a try yourself, see if you can figure out when to use the absolute value and when you don't have to. And I'm going to, so pause now, then come back and see how you did. So for this first one, I've got the 4th root of 3 different values. Because my index is even, I do have to be on high alert for taking the absolute value or introducing the absolute value into the problem. Here, the 4th root of 81, I can just type into the calculator. So to do a 4th root, again, 4 math 5, then I type in 81, and it gives me the principal 4th root, which is 3. And then if I take power and divide by index, I get x to the 1st, and then power divided by index for y is y to the 6th. Now, do I need absolute value? Because my index was even and x ended up being to the 1st power, I do need to put that in absolute value. So then down here, you can leave it like that, or you can rewrite it as 3y to the 6th and then absolute x. Okay, so because we had an even index and my exponent of x was 1, which is odd, then I need to put it in absolute value. If I take a look at this last problem, I have the square root of 3 different things, and because it is the square root, I need to be cautious that I'm on the lookout for any odd powers in my final answer, because those will have to be inside absolute value. If I square root 144, I get 12. Here the index is 2, so if I take half of each of those exponents, I get s to the 2nd and t to the 14th. Neither one of those are odd, so I don't need any absolute value, and we're good there. So in summary, how do I simplify radical expressions? Basically, you're just going to take the second or the third or the fourth root of each part individually. But I am going to put that last part on here. If the index is even and final answer has an odd power, then we need to use or apply whatever. Need to use absolute value bars. Okay. So that's kind of where we start with 6.1. Your homework is out of the textbook, so page 364, 12 through 36, every third problem, meaning you do problem 12. Oh my gosh. Do problem 12, then 15, then 18, then so on. Okay. If you want extra practice, you can do them all, but that's all I'm checking is 12 and so on. So, yeah, that's the end of section 6.1.